Hello, I'm going to share what I've been working on recently, and there's something very draft still, and not I would not say it is productized and can be used easily by anybody, but I thought it was so interesting that it's worth being shared. So here I am on GitHub, and you have PixInsight MCP. It's the idea is to do a MCP server for PixInsight. So you may not know what is an MCP server. So I have prepared a few slides to explain the idea. So the idea is that the artificial intelligence with Claude, but also with other artificial intelligence, has a new protocol called MCP that allows to expose APIs in a way that the LLM can directly dialogue with the APIs. And so implementing an MCP server on top of PixInsight allows to basically drive all the processes boxes in a way that that kind of work, I would say. We still have a few problems I will show you, but it does work well. So, and why? Well, we know it's very complex. We know that people like doing signal processing, so it's complex, but we like it because we spend time trying to improve. But anyway, sometimes you know that you could do much better if you had the time to do experiments with different values for your processing. You know, if you try 5 different ways of doing the background extraction, or how you would do, let's say, the stretching. All of this take a lot of time. And to process an image properly, I think it's like 20-25 steps easily. Many complex parameters, lot of work, and difficult to learn. And so with this approach here, the idea is more to say, okay, what do we want as a result? And the AI will be able to, based on what is documented on internet, based on what you tell the AI how to do. Of course, it's very easy to say, well, no, I strictly want to do like this, or I want to get inspiration from some other people, or from what the AI knows. And so, for example, here I would say, well, NGC 8900 NRGB. I have 180-second subs, and I use those filters, and I want natural color, visible dust lane, tight stars, and it's going to create a pipeline. Also here with 4 branches, and with trying to compare what works better, ABE or gradient correction. Well, you will see on my example, I have problems anyway with my on the example I took, problem with the background, which is not due to the processing, but also it's going to run kind of everything here, but trying many parameters that I can change on the go. And I see a result, and then I say, well, no, the dust line is not detailed enough. I want more contrast. So let's start again. It will modify a few parameters and start again the whole chain, which is really what we don't like, right? When we want to change something, having to start again the whole chain, or saving so many files on your hard drive is kind of the problem. Here, it's you will see it goes very quickly. So how does it work? So you take like an LLM agent, can be Claude Code, Codex, Cursor, I mean anything that can accept an MCP server declaration. And then I have, so the idea is that we have what I call a pipeline. So it's basically a little framework that allows to structure the definition of which processes we want to execute in which order. And this is the most critical part, the yellow and pink one here. So the idea is that the script and so the agent will exchange and discuss with PixInsight through a file bridge. We start a file monitor in PixInsight that will read new files that are put in a specific folder, which becomes kind of the way to discuss between the LLM and PixInsight. And then PixInsight will pick on and execute the different scripts that are given automatically. The idea is really that on the processing, as many different elements you need, you can branch out. So in the example I have here, I have the RGB branch and the stars that I'm going to work on, and the H alpha and the luminance. I can introduce some checkpoints and resume, so that if you say, well, I want to start again from modify this, the framework doesn't redo everything, but it can start from earlier checkpoints. The idea is that it exports JPEGs at each step so that it's possible to see and review. There is even a web pipeline editor, but for now, I think this is a bit too much from experience. Just staying on cloud and watching things, the resulting JPEG is enough. So really the idea then is that you can iterate. Finally, the principle of cloud is to have skills. And so the idea is that the skills are being improved as much as you use it. So the more you use it with different projects, and the more Claude will kind of strengthen the knowledge. Of course, this is knowledge that we can share too. Obviously, there are things that are personal in the way we can process, but there are things that are absolutely true or false. And so I can easily see that there will be skills, there will be libraries of skills, of Claude skills in the future for signal processing, because this is going to really dramatically accelerate how things can be done. In my opinion, it's really not about, well, you can say, well, what's the point if it's an AI that does it? But you can really learn the effects of each processes. You can experiment, you can watch, you can see the results much more quickly, in my opinion. And so I believe that as you do a lot more experiences and experiments, then the level you will reach will get stronger. It's not about, well, because it's AI, then I know nothing. I think it's because it's AI, it goes quicker, and thus you can experiment tons more things that will help you know more how to process your pictures. So you run, you review, you refine, and you can do this. So the first image I did 28 iterations. The second I did 3, and 3 because there was the knowledge of the first iterations of the first one. So I guess, like I said, the more you use it, and the more it goes quickly. So let's go for a demo. It's not prepared here. So first, if I go to the repository, the key thing is the PixInsight MCP Watcher .js. You have to run it here. So you do. So let's say first I go with one image. So I think it's in astronomy here. So I have this integration LXISF. Well, so view screen transfer function. So if I disable, we can see it's straight out of integration. I don't know, I think there is like 15 or 20 hours on the Leo triplet. And for now, it's not processed. I will launch the scripts. So PixInsight, I start it. So now it's listening. And by the way, when you do this, then PixInsight is not really usable. Like it's a bit, it's just listening externally. And also at the end, to stop it, I didn't find another way than to force kill, but that's okay. I mean, there is no big problem with it. And so here it is. Now I'm going to launch Claude Code. So Claude. So to launch Claude, you do Claude. I think just Claude like this. And so you can see it's my PixInsight MCP folder that I had checked out. And I would say something like, I want to process a new frame. It is in this folder. It is this file. That I have also opened in PixInsight. It is a nail capture, 15-20 hours signal that is just straight out of the integration. Please do the usual processing for a null frame up to final stretching noise steps. I don't have yet acquisitions for RVB. It is just to demo a bit. Okay, now I say go. So it's going to think. And so now it says kill PixInsight pipeline. So basically Claude is taking understanding of how to leverage the thing. And it say, well, I'm going to set up a NL-only processing workflow for NGC 368. So I will probably cut this, or you will accelerate, because I don't want to spend too much time working on the video. Sorry for this. And so then you have to confirm a few things here. So basically, if I was already in an existing project where I just iterating on the project, I could have just launched you something that is already working for the automation part, but at least here you see all the steps. So we can see live image, SPCC, SCNR, plate solver. It's starting to see what to build as a flow. Obviously, like Star Exterminator with JSON is not going to be so interesting, but we'll see. So what it's doing now, it's building the scripts, and then it's going to use this the server for starting. So it's okay, now I have a clear view of what I want to do. and so it's going to do the configuration for this. And because it's the first time that I'm doing just L, it's modifying a bit the generic framework. So it's saying yes. So like I said, it's still very fresh and not like the first time I'm doing an L1. So it's looking a bit at the pipeline to adapt. After that, I will try to launch it on something where I have R, V, B, L, and H, so that you can see also. Okay, so the script, which was like thought for all frames, is now L proof, L only proof, um, and it's generating the configuration to start the processing. This is usually a very quick step. And it says like NGC 368 is the Hamburger Galaxy, an edge on Galaxy similar to NGC 891. I use the Galaxy appropriate settings, which means that it's going to do a bit of multi-scale transform. So we see the various tasks. It's like it added the L-only mode to the pipeline, which didn't exist. It's creating the ngc L-only config, which is done now. And so now it's starting the pipeline. So it just checked if the thing is on. So it say yes, and I can see that it's already open, and now it starts. So if I go here, we can see that it's starting all the process. So it's gonna chain everything. And so it was quite long because it was the first time I was doing a L. So all the preliminary steps that were about adapting the script next time would not be like this. So we will see just after if I go process another one. So as we see, it's doing the various things. Now it's doing blur. And we have this new model of blur that we are happy of. And if I go back to Claude, as you see, Claude is also monitoring what's happening, and we see Bixty sharpen. So it's saving the different pictures at the different steps, so that you can, so not only you can see it, but also the model itself can see it sometimes to check what is adapted. So, like I said, I think I have, I even have one, but yeah, so there is even a web application that I have done where you can see the different steps and see a screenshot for all of them, but I'm not using it because I didn't think it was useful. So we can see stars being processed here. Honestly, doing the starless is a bit useless. It's a bit stupid here, I would say, but anyway. Now doing noise exterminator. And we can see it's doing masks. So yeah, I have a problem here as the halo of the big star that remains anyway. So it's doing a mask because then it's going to do the multi-scale transform using the mask. And local histogram equalization. And by the way, I'm definitely not a professional. We are, I mean, I am with some professionals, but I've just joined just a year ago, and in the way I do captures, the quality of my mount, and all of that, I have plenty of problems to still solve to reach a great place. So I'm not saying here that the processing is the right one. I think it's more just to understand the how it works. Then because then you can do what you want with it. It's maybe not the right step, but you can then guide the AI to do the way you absolutely want. So still doing the pipeline. I think we are more at the end now, so we're going to see the result. Also, meanwhile, we can see that this is the JSON that has all the configurations of what has been done. So also what is nice is that you can archive what you have done very easily, all the steps, all the values, midstone boost, fine contrast. So it's doing like a sort of GHS with DB, you have all the algorithm. Then it did 2 passes here, and you can see how it has done it. So sounds like we are approaching the end. Well, not very happy of the result, to be fair. But so we have a first iteration here, and well, it's not nice. Like it's a way too. We can see that this is way too. I think the local histogram equalization was really bad, and then other problems I can see. So I'm going to say, let me look at some intermediate previews to assess the processing quality. So it's itself looking at the result. And so here you see, I mean, the result looks great. Well, I'm sorry, but it's not great at all. So it noticed some problems, and I will give my own comments. So I will say this is too, so this is way too processed. I don't think we need to remove stars for L-only processing. It causes problems. Also, the local histogram equalization is way too strong here. Finally, I can see some noise. Okay, and then I give it, and it's going to iterate. So why we're doing this? As we can see here, I can iterate, and very quickly I'm going to get something that I'm happy with, and I can tune the details, or I can say, well, what about using this process and this type of thing. So it's going to read what I said. There is no reason to do star removal, just create artifacts for nothing. Disable HDTR, turn down a bit. So I think that's the one who make it way over processed. So it's what it's doing. It's changing the JSON part, so kind of configuration. And it says, well, iteration 2, star processing removed, disabled, LHE amount 0.25, 0.15, disable the HDR part, which I think was what causing this fake look. And and here, so it's just one gentle pass. I think they should have gone with the 2 passes for GHS. So I think this one is bad. I will tell him to keep the 2 passes actually for next time. But anyway, it's starting. So as you see here, it's running the thing again, and it's going to process and process. So from the experience I had, I just want to mention more like real life experience. I did a couple of things recently. The first one is I run it with that's the one where I build it. So I literally build it with it. So I run it with this one here. This one took me I ended up with 6 iterations, but really it was actually I think after 3 it was kind of okay. I still have a problem with some of the stars. I mean, but that's really because all my raw frames are not good at all. I mean, everybody will throw away all my frames, but I keep them because otherwise I have nothing to work on. And then, you know, here it's still missing some noise aspects, but I think it was quite decent, and it was very quick that I converged toward this. And I had another one which I did here. So I will show you the result directly on my website actually. So I do observations in the Astro Lentejo, in the Astro Remote Observatory. It's a nice observatory in Portugal. I think we do have one seat, by the way, if someone is interested. It's a great spot between 2 and 3 for Bortle scale. And absolutely amazing astrophotographers there, namely Francis Boson, but many others that are really very good. So we have plenty of inspiration there to progress. I definitely recommend to join. And I just wanted to show this one here, which is the first result I had using this technique. And so, okay, I fairly recognize it's very red, but it's also because most of the signal comes from H, so could not add a lot of nuances. But I mean, I was very happy. I think it was still missing a pass of noise reduction, but overall, lots of details, and I was happy to be able to get some of the little aspects here. I was really happy of this, and for me, although I spent like I mentioned, it was 28 iterations. I learned a lot of things. I could experiment, and it was a very progressive appearance of the details. So I don't think the experience is so bad by the fact that it is AI. It's still doing processing, and you're still learning a lot of things. Okay, I'm going to stop.